Hello, welcome to a demonstration on how to develop or perform a multiple regression analysis using SPSS as well as Excel. We are actually going to use this particular data set to use both applications so that you can actually see the differences between the two. So multiple regression analysis, of course, is a statistical technique that is used to examine the relationship between multiple independent variables and dependent variable. So in this particular case, the data set we have, it's actually a hotel facility where they want to measure independent variables like comfort, amenities, in-house dining against the overall satisfaction, right? So we want to examine these independent variables to see if they are strong predictors of the dependent variable, which is the overall satisfaction. So that's a very useful data set that we can actually use. And for practical purposes, it's quite easy to identify with it. And so it will be interesting to see what the data will actually reveal. So what you'll notice is that both SPSS and Excel can actually be used to perform multiple regression analysis. Although, of course, SPSS is generally considered more specialized, much more sophisticated, as a powerful tool for statistical analysis because of its origins. It was developed specifically for statistical analysis, but Excel has actually been adapting to a variety of applications so that it can be useful in all those areas. Now, what you find is that once we've generated the statistical elements, you will find that SPSS will generate an output. It will actually create an output file, which will include coefficients, standard errors, p-values, and r-square, etc. Whereas Excel will actually output the information, on either on a new worksheet or on the same page. Again, it will also include the regression coefficients, standard errors, r-square, etc. Right, so we'll be able to kind of show side by side so that you can see the similarities and differences between the two. But in terms of what is actually generated, it's generally the same. Okay, so just as an add-on here, you will observe that both SPSS and Excel can actually perform the multiple regression analysis, as I've already indicated, but you will find that SPSS offers more advanced statistical analysis feature, which is a much richer in output and greater flexibility for complex analysis, for obvious reasons. Okay, so we switch over to SPSS. SPSS, right? Okay, there we are. We are now in SPSS, and what we will need to import the data from Excel. So we go ahead and say File, Import Data, and it's from Excel file. And then, of course, here we look up the data where it is, and it should be beachfront hotels. That's the data file we need. We go ahead and open, and after a few seconds, you should be able to see the dialog box, and it's kind of just showing us how it's going to look. That looks about right, so we'll go ahead and say OK. So it should come up, and it looks about right, and we can go into the variable view so that we can take a closer look and see if it's about what we are actually looking for. Yeah, that's about right. Okay, so it looks like it looks good, so we go back to data view. Now, while we're here, we can go ahead and generate multiple regression statistics. So we go to Analyze, and under Analyze, we should be able to see Regression. And under Regression, we should be able to see Linear. All right, so then once we're there, we can now determine what is our dependent variable. We know it's overall, right? That's our dependent variable. That's what we want to predict. And then what are our independent variables? Comfort is one of them. Amenities is one of them. And in-house dining is the third one. Okay, and then here under statistics, again, if we wanted to add anything else, we could actually do that. In many cases, many would want to check the collinearity diagnostic so that they can see if there's any two independent variables that are explaining the same thing, right? But in this particular case, we are much more approaching this in a much more generalized way, so we are not really interested in that. So you can just say continue, and we just go ahead and say okay and generate the statistics. And now what you notice is that SPSS will actually create a separate output file, right? Okay, away from our original data. So we're now able to actually see what is in here. Okay, so now before we interpret the statistics, we can actually go ahead and generate the same multiple regression statistics using Excel. But otherwise, here we will actually keep this open so that we'll be able to split the screen so that we'll be able to see side by side as we go through the interpretation of the two outcomes, because generally we want to be able to see if there's any similarities in the statistics that were actually generated, okay, and what the differences are likely to be. Okay, so this is SPSS, so we move over to Excel, right? Okay, so it's the same file, so I can get this narration out of the way because I don't need it for now. Now, all we have to do here is to figure out how we can perform the same activity in Excel. Now in Excel, you have to go to Data tab. So when you click on it, you should be able to see data analysis here. Now, by default, it does not just show up. You have to actually activate it. And to activate it, you go to File, and you go to Options. And under Options, you see Add-ins. And then Manage Excel Add-ins will show up here, and then you click on Go. And then here you put a check mark on Analysis Toolpack. That's how it shows up as data analysis right there. Okay, right, so we click on it, and then it opens up a dialog box so that we can select the activity that we want to do, right? And in this case, it's regression, right? And then we have a dialog box here that's actually asking us to enter the dependent variable. So it's pretty similar to what we saw in SPSS, right? You begin by being prompted to enter the dependent variable. In this case, we know this is our dependent variable. Please note that I've actually included the label, right, which is the column heading right there. And also we do the same here. Okay. Now those are some small differences that you tend to find. I didn't have to specify that in SPSS, but here in Excel we have to, because it's a little more manual. In SPSS, I just had to specify the variable and it knew what to pick up. So here we have to put a check mark on labels to show that the first item on the selection is actually a label, right? Okay. And of course, confidence level by default is going to be 95%, so we don't even have to put a check mark there. It knows that already. Okay, so then where do we want our results to be? In SPSS, we didn't have to specify that because it was automatically generating a brand new file on its own, which is called the output file. So in this case, I want to put this information on the same page as the data itself, and then I put my pointer inside this box before I select where the first output should be on this particular screen. It should actually begin in, let's say, G2, like that. You can see it types in the cell reference for me. And then once this is done, we just go ahead and say, okay. And then this is how Excel will generate the regression statistics output. So what I have to do is to make sure that I can clean up a little bit so that I can see all the values showing up. And now what you also notice in Excel is that the the last 4 columns here are redundant. So you can see lower 95, upper 95, lower 95. The last 4, they're actually redundant. So I can get rid of the last 2 columns because I don't need them, right? They're duplicated. Okay, so now beyond this, now it's time for us to compare the two outcomes. So I want to kind of minimize. I want to minimize the screen here. Let me see if I can move to the right a little bit more. There we go. Okay. Right. Okay. Maybe expand it a little bit more, something like that. It looks like this fits nicely, but anyway, I can still minimize it so that it's a lot easier for me to fully take full advantage of how much space on the screen I have. Beautiful. All right, so now we can see that the model summary is pretty much the equivalent of the summary output here for regression statistics, right? We're actually able to see that the multiple R is pretty much similar, even though this one here is 2 3 decimal places and that one is 2 4 decimal places, right? So these numbers are actually checking out. They are pretty similar. So now, because we are actually able to see that, we can actually begin to interpret them. And the multiple R, in this particular case, in Excel, we call it multiple R. Here it's just R, which is regression. It's explaining how much of the variation is being explained. In other words, the overall satisfaction at this particular hotel of as predicted by the 3 independent variables, the comfort, amenities, and in-house dining. They explain it as about 87% of the variation in the satisfaction, right? So which means that the other 13% we don't know. There could be other variables out there that could be included in this particular model, right? And so that checks out. That checks out too. Now the R square, you will see that there is an R square and then adjusted R square. Adjusted R square is adjusted for the sample size, and it's actually consistent here in Excel as well. Those two numbers are about the same. And generally speaking, it's recommended to use adjusted R square, the one that is more conservative. And of course, we do have the standard error estimate. It's pretty similar to that. And of course, we do know that our sample size, which is additional information provided here, our sample size is actually 20, right? That's our sample size. Otherwise, the ANOVA, it's pretty similar, ANOVA here as well. And of course, the only difference that you tend to find is that on the significance, here it's saying it's less than 0.001, which means it's statistically significant because it's also lower than 0.05. But now here, when you actually look in Excel, Excel does not quite interpret it that way because it uses a scientific notation, right? That's why you see there's a E-05 right there. So what does this actually mean? It means that this value is actually to 5 decimal places, which means we say 0.5 decimal, so we count up to 4, 1, 2, 3, 4. Then a 5th decimal place, that's the way the 4, 5, 2, 3, 8, 6 will actually begin. When I press enter, you can see that's how we've actually arrived at that. So this is effectively something that is lower than 0.001, which is consistent with what you see in the SPSS right there. Okay, so it's important to understand what this actually means. Whenever you see a character together with numbers, it means that it's a scientific notation in this particular regard. So, okay, so far so good, right? Everything else is kind of checking out. Even when you look at the sum of squares for the regression and the residual, they are pretty much the same numbers out there. Now, when you go further down now to the coefficient section, again, here we see that we begin with unstandardized coefficients. Here we just call it coefficient, and the numbers, they check out as well. All right, so here we can see the intercept or our constant is pretty similar, and then the other coefficients, right? Comfort, amenities, and in-house dining. So basically the coefficients are simply telling us that for every change by 1 unit in comfort, this is by how much the overall satisfaction will change. The same with amenities. It's actually higher with amenities. It's even higher with in-house dining, right? So it's simply telling you by how much the overall satisfaction will change whenever the independent variable is actually increased by 1 additional unit, right? But then in Excel now it goes further, right? It does say that for example, comfort, for every change in comfort, the overall satisfaction will change by 0.11, but it can be as little as negative 16 and can be as high as 0.38. So it actually gives you the range, whereas SPSS does not give you the range in this particular regard. Okay, so what else do we have here? What else do we have? Amenities, again, we can see that 0.24, but it can be as low as 0.15, can be as high as 0.34. In-house dining is 0.25 and can be as low as 0.12, can be as high as 0.38. Otherwise, the p-values are fairly straightforward, and they're pretty much consistent here. This equivalent is significant here, right? And again, we can see that comfort is not statistically significant. That's also true here. Maybe it's because the lowest is that can actually be negative, right? Even though it can be as high as 0.38. So comfort, people are not really worried about comfort. They're much more worried about amenities and the in-house dining, right? That's quite interesting for this particular data set. So here again, we can see that it does check out that amenities is lower than 0.001, and whereas in-house is again it's exactly 0.001. So they are all statistically significant because they're lower than 0.05 anyway, except the comfort, right? So again, you can see everything checks out. All right, and again, remember that the circumstances under which you can actually use Excel, again, it's a question of, first of all, if you're doing that for the purpose of publishing a paper, scientific research, you want to check with the publisher. But otherwise, for practice purposes, yes, you can use it anytime. But if you want more sophisticated statistical analysis, the SPSS is the way to go. But of course, SPSS is not easily available. So for purpose of gaining more practice, it's always nice to use Excel because it's there. You don't have to pay anything extra. But of course, remembering that SPSS in statistical analysis is far much superior because it's designed specifically for that, and it's widely accepted in scientific research. Otherwise, that's all I have for you. I hope you found this demonstration useful, and hopefully it will add a little bit more skill to your portfolio, right? So that at least you understand the difference between the two and how you actually go about using the two very useful applications. Otherwise, like the video, share the video, and be sure to subscribe to the channel. Bye for now.